Thaka. Welcome back to Techno Education Academy. In this video lecture, we will derive Eulers Equation of Motion and Bernoulli's equation. For that purpose, we require to think on the study of the motion of the fluid. For deriving this equation, we require to learn motion study of the fluid. We can consider any fluid element or on that fluid element there is a forces are acting. So this is a part of dynamics of flow. Part of dynamics of flow. Dynamics means here we can consider the forces which can apply on the fluid element. So whenever the word comes motion, it means we have to learn Newton's law. Newton's law of motion. So for that purpose, we have studied second law of motion. In the second law, Newton said that F is equal to ma. Here F is a number of forces which can apply on any fluid element, and m is a mass of the fluid, and a is the acceleration. Acceleration, it means change in velocity with respect to time. Consider as a important step. Now, from that important step, F is equal to ma. Here, number of forces which is applied on the fluid are, list of the forces are gravity force Fg, pressure force Fp, viscous force Fv, turbulent force Ft, and compressible force Fc. These are number of 5 forces are always applied on the fluid element. So F is nothing but the net force applied on the fluid element is equal to mass into acceleration. Acceleration means change in velocity with respect to time. So there is a net force Fx is equal to Fg gravity force plus pressure force plus viscous force plus turbulent force plus compressible force. If we neglecting the compressibility force, because here we take assumption the fluid is incompressible. So we can neglect compressible force. And if we neglect the compressible force, then the equation is like that. Fx is equal to gravity force plus pressure force plus viscous force plus turbulent force. It is nothing but it is called Reynolds equation of motion. Now further we find out the Navier-stokes equation. It means here we can neglecting now turbulent force, so we can get Fx is equal to gravity force plus pressure force plus viscous force only. These 3 forces are only considering in the Navier-stokes equation. These forces are considered for the Navier-stokes equations, and if we considering the turbulent force, then it is Reynolds equation, and if we considering the compressible force, then there is a compressibility in nature. It means there is a change in density of the fluid. Now we can start the derivation of Eulers Equation of Motion. These are the fundamental things that I discuss with you. What do you mean by Reynolds equation, what do you mean by Navier-stokes equation. And now we can start to derive Euler's equation of motion. For that purpose, we can take a fluid element, that is, I am drawing at present fluid element like that. This is the fluid element. Is it visible to all? The fluid element having the central axis and the weight of the element is W capital. It means m into g, where m is a mass. It means density into volume into g, where volume is nothing but the area into length. This is the length of the element. It is the length of element ds. So now volume is nothing but area into length into g. So this is the equation where weight m into g, where m is a mass and mass is nothing but density into volume into g. Now volume is nothing but area into ds. ds is the length of our fluid element. Now we can consider pressure force in both direction in perpendicular. Pressure force P into dA. Here it is a area dA. Now this is the area. Here also area dA. But this is ds length. After the ds length, fluid element, inside the fluid element there is something change in the pressure from the inlet to outlet. The change is like that: P plus del P by del S into ds multiplied by dA, like that. So the inlet pressure is PdA, pressure force is PdA, and outlet condition pressure force is P plus del P by del S into ds into dA. Now the angle is theta from the axis. Okay. So from that theta angle there is a weight mg. Weight is always perpendicular, but weight is always downward in direction. So we can take weight is equal to mg, and there is an angle between the axis and the weight of the fluid element line is theta. We can take theta is the angle between the direction of the flow and the line of action of the weight of element. This is the direction of the flow and line of action of the weight. The angle between the line of action of the weight and the direction of the flow is theta. Now, according to the Newton's law, Fx is equal to m. Here Fx, in our case Fx is nothing but it is a pressure force and the weight. Both are our forces. So net force is equal to mass into acceleration. Now we can write down Fx in the our condition. In our condition, Fx is in the force of pressure force and weight. So we can considering direction like that is positive direction. Direction like that is negative. Direction of the line of action of the flow is taken as a positive direction, and in the opposite direction P plus del P by del S into ds into dA, it is the opposite pressure force at the outlet section is considered as a negative direction. So we can write that P dA minus P plus del P by del S into ds into d minus rho g dA ds cos theta. Why cos theta here? Because like that the angle is theta. This is the weight element, line of action of the weight. It is nothing but dz, and this is the ds. So we can write down the fluid element in terms of ds direction. In terms of, we can reflect that in terms of ds direction. So we can consider, we can take rho g dA ds cos theta. Why? Because adjacent side of the theta is nothing but it is cos theta, and front side of the theta it is called the sin theta. So we can take adjacent side like ds, so it is a cos theta. So ds cos theta means this component ds cos theta. So rho g dA ds cos theta is equal to mass nothing but density into volume dA into ds into acceleration s direction in the acceleration. Okay, so I think these things are clear to all. Now I am writing one another time this equation because is it not easily available or visible with you. So p plus del p by del s into ds into dA minus rho g dA ds cos theta is equal to rho dA ds cos theta into s. This is the equation. Now we can further simplify this equation. So we can get these terms are neglected, p dA. So left with this term del p by del s into ds into dA minus rho g dA ds cos theta is equal to rho dA ds cos theta into s. It means acceleration. Acceleration means velocity with respect to time. So we can write down like that. Now further simplify this equation, dV by dt, write it in terms of the partial fraction because velocity is a function of space and time both. So we can write down if any variable is dependent on the two variable, it means we can write the ordinary differential in the form of partial form also. So del v by del s into del s by del t plus del v by del t. This is the space coordinate, this is the time coordinate. So space and time dependent on the velocity. So we can get v del v by del s plus del v by del t. V del v by del s is the convective part and del v by del t is a local part. It means local acceleration and convective acceleration. So put these two terms in our above equation del v by del t. But this is the case of steady flow. It means del v by del t terms 0. So we can write dv by dt is equal to v del v by del s. Why? Because del v by del t is 0. Our condition is steady flow. So in the steady flow there is no need of time. The time is constant throughout the flow. There is no change with respect to time. So del v by del t is 0. So we can get del v by del t is equal to v del v by del s. It means the equation is changes in the form like that. Minus del p by del s into ds into dA minus rho g dA ds cos theta is equal to rho dA ds v del v by del s. Now dividing whole equation by rho ds dA. So we can get new equation. Divide the whole equation by rho dA ds. So we can get minus del P by del S divided by rho minus G cos theta is equal to V del V by del S. Further simplifying this equation, we can put cos theta, because value of cos theta from this triangle theta, this is the dz, this is the ds, so cos theta is equal to dz by ds. Put here cos theta is equal to dz by ds, so we can get 1 by rho del P by del S minus G dz by ds is equal to V del V by del S. Now we can change this right hand side into left hand side, so minus is converted into the plus. So we can get the new equation 1 upon rho del P by del S plus G dz by ds is equal to plus V del V by del S is equal to 0. So we can get the equation like del P by rho, because here del S is constant, G dz plus V del V is equal to 0. So dP by rho partial form converted into the ordinary form, G dz plus V dV is equal to 0. The above equation or this equation is called Eulers Equation of motion. Now we can further integrating this equation, dP by rho plus G dz plus V dV is equal to 0. So we can get P by rho plus Gz plus V square by 2 is equal to constant, and this equation is nothing but it is called Bernoulli's equation of motion for incompressible and steady flow. For incompressible and steady flow. The following assumptions we can take for these derivations are like that. First assumption, fluid is ideal. Second assumption, the flow is steady. And third assumption, the flow is incompressible. And fourth, the flow is irreversible. Thank you, students.